Good morning, Alex. Good morning, Cynthia. All right, every day, get used to it.
Really lost my volunteers. I have no idea what it is.
I could just get that time.
So grab your periodic tables, grab a calculator, and something to write with, Isha. Take it over.
Oh, can we take it? You didn't know?
You read it yesterday?
Oh my god, no. I did not see that.
Is there like 4?
There was no early bell. There was no 5 minutes.
They just did it that one time, and that was it.
You weren't there. Let me just check out my videos. I did really bad. I had confidence. I was like, no, this is not hard. Bro, I studied a lot of math.
Yeah, no,
There
it
was
was like
one
one.
math problem.
That was
The
one.
entire thing. So I was like, oh, I'm not going to know math. I needed to know math. I finally understood it, and I did a ton of problems. There was one math.
One math, yeah.
Why is it so bad today? What the hell?
I don't know. It's so bad.
It literally was your magic. I don't want two to come. I want you to do school. Hi I just got this email from Sequest that says I can take college classes during my junior or senior year of high school. Oh, that's okay.
Oh,
That's not as bad as I thought it would be.
okay.
What'd you get? 51 out of 75. You can get like a 44. Yeah. I know. I did it. You can retake it. You have to do corrections. No, it says you need to do corrections to retake.
So I think.
You scored too good, too bad.
Wait, what'd you do?
I got 68%. I should have just gone with the 50 and then retook it.
Yeah, you can't retake it.
Oh, wait, in the 60%, so wouldn't that be 68?
Yeah, you can.
Yeah, you can do it. You can
Okay.
retake it.
Isn't it 77?
68.
60s.
She got 60.
Yeah, she got 68%. And that's
Isn't
60s.
isn't there 88 points?
No, like she got
There's
68%. And
There's-
it's the 60s
Oh.
percent, yeah.
Oh, 60s.
Yes.
Wait. Or low.
60s
Okay.
and
Oh my god.
No, not just 60s. Not just
I was like, are you
60s.
joking me?
Okay, so I still have a chance.
Yes, you could
Okay,
retake it.
I still can't. Maybe we should go studying again.
Period. That's another excuse.
I got 70.
100%.
This time you actually study, okay?
Good morning, ladies and gentlemen. How are we doing today? Good. Please put away your phones, your headphones. Get your computers out. Get ready to go. I will hand back your tests in just a moment, ladies and gentlemen. Let me get attendance.
Yeah, we have a math quiz. Yeah, I give it up. We have a math test on
Look,
Tuesday.
my bangs are here back to
Oh,
normal.
it's just a quiz.
I don't
It's
have
just
a
a
middle
quiz
part
today.
anymore.
We have a test on Tuesday on my birthday.
If I do this for Valentine's
That
Day.
means that you're gonna get 100%.
No, it isn't. That
If I
means
do
you're gonna
this for
fail.
Valentine's Day.
Yeah.
I'm not even in it anymore.
Okay, I'll get a cross.
You're gonna get
Are you gonna wear it?
please.
Um,
You're gonna get
Her
answer.
king, his queen,
I don't know.
alpha wolf.
but maybe it's
No,
Yeah.
no,
blue one matching hair. I don't know about that.
no! Gosh darn it! It's blocked.
I'm so excited for all this blue.
I was
Look,
going
do you
with-
want? I'm gonna get this for me and Levi for Valentine's Day.
I think you have to wear them on the same day too.
Yeah.
Yeah.
Yeah, for sure.
Yeah.
Can't just show him saying her name.
Definitely.
Yeah, I got a
For sure,
73
for
and
sure.
73.
Huh? Yeah, that's
What?
literally us.
Okay,
That's literally us.
Okay, I see.
I'll explain.
Yeah, I
see the big
Explain. We're done talking about
Yeah. Oh my god.
Oh my god, what was that guy's name in our bathroom?
What'd you get?
He said he didn't want that stuff.
Grant?
You said.
I told Grant that if he got that for his girlfriend, then she would lock in.
He didn't listen
it.
to me.
Should lock it. It was lock it.
Like,
Be really.
Focus.
like
Like,
focus, like, and like.
And love
It's
it.
the opposite of
She was in love with it.
Yeah,
Oh,
like she would never leave.
Yeah.
And he was like,
locked it.
she would
Sure.
lock out. And I was like, no, she wouldn't.
Really?
Like, she would literally love me. Oh.
Also-
I don't need to see that right now.
This
Let's
is
not
so
go back to
funny.
it.
I've never seen a zero so big.
Levi?
Why did I have to make it $1?
What? What do you mean?
you gotta do the teacher thing where they hand it to you upside down.
Why did I get an X on this?
You gotta do the.
Daniela?
What's with that zero right there? Why is it so big? Let's do it a little smaller.
Bro, I got this so
Yeah.
wrong. I literally said,
Fresh, don't
inside
break.
matters, don't judge a book by its cover. And that was my hashtag because I had no idea what it meant.
Yeah, I
So you're
literally
gonna
just
do the
it
teacher
was
thing where,
like-
where they can do the paper upside down because they don't like to see.
That's crazy. Oh, I got these right. No way, I got that right.
I got this one wrong. Look, you see the 3 question marks? That meant that I had no idea what I was talking about.
What were you on about?
Oh, got that one.
All right, ladies and gentlemen, we will go over the answers for this in just a moment. But right now, what you need to do is you need to double check my arithmetic. So make sure that I added the points on each page correctly and that they total up to the number that is down in the corner. Then make sure to add up the corners to make sure that is the number that is on the top of the test, because that is how it goes into the grade book. So if I made a mistake on mathematics, which I do in my head, I do not use the calculator for, and I shorted you 10 points, you need to let me know, please. Okay?
The 0, the X is through it. That's... What the heck? This is so wrong. The X is through everything I say. It's so wrong.
What?
Moving.
What?
I have no idea.
What?
I said the law of conservation. I have no idea what those mean. So I said the object must be moving. And like the Newton's law of motion or whatever, I just did that one because I was like, that's the only law I
Really,
know.
did you get the bonus question?
Electric?
What?
Charge for protons electric.
I knew one of these were 0.
Put 0 for all of them.
I did. I put point. I needed to be safe.
You're like, I'll get one
I knew
eventually.
Yeah, the only problem is by putting 0 for all of them, I grade the first 2.
And the
which
last
were
one
both
was the one
wrong,
that
and the last one was the only one that was correct.
Oh shoot!
That was the same with me.
Electric. I feel like my electric charge. I have no idea what that meant.
No idea.
Did you get that?
You had it mixed up.
What?
I forgot to do this
Because
one.
we're both one AMU and now I'm 0.
No way.
You mixed them up. Or matter is always moving.
Sometimes I think I need to what is this? I didn't get this.
6 8s.
Oh, I didn't get this.
No, you got 6 8s.
Oh look!
Oh, I did it.
I did
it. What's the less point for?
You can get level points.
So
Hey.
I just rewrote
It's 5
the.
plus 1 point, but he wrote 4 points.
Now, please listen.
I think that's wrong.
When I go through this,
I got
Something.
you're not listening. And how do I know? Because you're talking. And if you're talking, you're not listening. And you have 2 ears and 1 mouth. You should listen twice as much as you talk. Okay? When I go through this, if you think I graded something incorrectly, please put a note. On the top, please recheck number 7. Please recheck number 10. Please recheck whatever one you think it is I need to recheck. And I will do that, ladies and gentlemen. Okay? Again, but you need to put a note on it. You need to put a mark by it. Don't just hand it back to me and assume that I'm going to recheck everything. Okay? Jara, Nadia, put away your phones,
That was the
please.
one I was
Thank
I'm
you.
sorry.
Go ahead.
I don't know if this is.
I am going to get to each one of these.
No,
So,
but like I don't know if I'm wrong or is it just.
okay. If it says SF, that means your sig figs were not correct, then you lost a point for it.
Okay.
Which I will get to when I explain the question as well. But just relax, okay? So, first problem was worth 6 points, ladies and gentlemen. The science of the study of matter, its structure, properties, composition, and the changes it undergoes. Science, matter, structure, properties, composition, changes it undergoes. That's where the 6 points come from. For number 2, these were your answers for kinetic energy. These were the 3 for potential energy. 2 points for each one for a total of 4. Okay, for number 3, ladies and gentlemen. Okay, for objects to be at the same temperature. Everything in this room is at the same temperature except for the electronics. However, this desk top has more heat than this can. Why? The desktop has more particles, and heat is the sum of kinetic energy. And you needed to tell me that heat was the sum of kinetic energy, because then it matters how many particles are there. So again, 2 objects at the same temperature, if there are more particles of one than the other, it will contain more heat. For the second one, explain how it is possible for 2 objects to have the same kinetic energy to finish a race at different times, and which one would win the race. Well, kinetic energy depends on mass and velocity. The object with the heavier mass is going to be moving slower, so therefore the lighter object will win the race. The last question. Explain how 2 different objects can have the same amount of heat yet be at different temperatures. Well, the 2 objects do not have to be the same size. The colder object needs to be much larger than the hotter object, though, because again, heat is the sum of kinetic energy. So therefore, if you have an object that is very cold, but it has a lot of particles, it could still have a lot of heat. If you have a hot object, you do not need many particles to have a lot of heat. Questions on any of those? Okay. Yes.
You didn't give me 1 point.
What's that?
You didn't give me 1 point. You gave me 5 out of 6, and I got 6 out of 6.
Okay, on which one?
On the first one,
Okay, read me your definition.
the science of study of matter, its structure, properties, composition, and change undergo.
I will check that for you. Let me see. Yep, you're right. I should have given you 6.
Just give me my points.
So put a note on there, and I will go back and I will recheck it. Were you asking me the same question of hers? So you're her lawyer now? All right. So for the first one, ladies and gentlemen, your object had to have height and no motion. Height and no motion. For the second one, it had to be moving but no height. For the third one, it had to be both moving and have height. And for the last one, it had to be not moving and have no height. Now, for the bottom one, ladies and gentlemen, a lot of different answers were accepted for the answer. My hashtag was X depends on size in no. Meaning X depends on size, intensive, no, it doesn't. Something along those lines, but that's what intensive and extensive means. Now, people screwed up the intensive and extensive. Intensive properties are ones that do not depend on sample size, like color, matte or color, smell, density, boiling point, specific heat, melting point. Mass and volume were the 2 that were extensive. You can write on them. They're yours. You bet. You bet.
Do we get to keep these, right?
You will, yeah, because the person who needs to make it up is doing it next door. Questions? By the way, you only needed to do 2 of these 4. So even though they're 2, 2, 2, 2, you only needed to do 2 of them, and then down here you needed to do all of those. Jacqueline. Specific heat. You could have also used color, chemical properties, flammability, reactivity, anything like that.
What's the hashtag?
The hashtag X depends on size in, no. So extensive, it depends on the size of a sample, intensive does not. So something that conveyed that. Other questions?
Wait, what's the hashtag? Wait, sorry. I'm sorry.
No, I
I'm
understand,
sorry,
but literally, that was just the question that was asked.
Depends on
The difference between these two is extensive depends on the size, intensive does not. So you had to somehow convey that in your hashtag.
Oh, not my inside matters. Don't drink a book by its cover.
Correct. Yes.
So
My
what does
sister
specific heat
counted.
be boiling?
Boiling is not a property. Boiling is an action.
An intensive example.
Right, but intensive property. So it has to be boiling point.
But
Boiling,
Oh,
go ahead.
straight up boiling is not.
straight up boiling is not a property. It is a change.
But it's an
boiling point.
so an extensive example is not boiling. Boiling is energy.
Intensive, she means.
Neither one, because boiling is not a property.
So it
Boiling
has to be
is a
boiling.
change. Correct.
Oh.
It has to be a property first before it can be intensive and extensive. Someone also put down chemical. Chemical is not anything until you put chemical property at the end of it. Okay? All chemical properties are intensive. All right. I could do number 6 in 4 words. There they are. Property, prediction, change, action. If you put prediction, if you put trait, if you put characteristic, I gave you credit for those. If you put action, happening, something like that, I give you credit. Now again, chemical changes, rusting, tarnishing, rotting, corroding, burning. Then the property would be to be able to rust, to be able to corrode, to be able to rot, being flammable. Physical change, melting, boiling. The property would be melting point, boiling point, things of that nature. Dissolving would be the change. Being able to dissolve would be the property.
Is it like when we retake it? Is it the same test or is it
No.
a different? Like it's completely different.
Well, it is different. It is the same material, basically, because this is the material from the unit.
Change action.
Okay? So I'm still going to ask you about properties, changes,
Yeah.
intensive, extensive, chemical, physical, but I'll do it in a different way. So the topics are not going to change, but the questions will. Okay? 3 signs of a chemical change: unexpected change in color, change in energy, gas released, and the 4th was a precipitate forms. So any of those 3. By the way, if you put down a gas released and bubbles, that's the same thing. Okay? Questions? There you go, ladies and gentlemen. There are all the graphs. Constant means the line is straight. Non-constant means it is curved. Direct means it's going up. Inverse means it's going down. Questions? Okay. Compound, element, homogeneous, heterogeneous. Why? Unevenly distributed mixture of things. Mixture just means 2 things together, physically combined. Evenly distributed, 2 things together. Okay? Physically combined. Periodic table. So that's this. Compound, two or more substances chemically combined. Here is what I wanted for the number 10. One word, two words, one word. Questions?
Special drop.
Okay. There's your charges, there's your locations, there's your masses. You needed to do 2 out of 3 in each column. I didn't care which 2 you did. If you did all 3, I graded the first 2. If the first 2 were wrong and the third one was right, well, that was your choice. Number 12, you could interchange the words energy and matter, but the definition is exactly the same. Cannot be created or destroyed, only changed. You had to include both parts. If you didn't include the only changed, you got 1 out of 2. So, here, mass over volume. Volume, you have to subtract these 2 numbers. That number in sig figs with that unit gives you a total of 5 points. If you didn't have your sig figs correct, if you didn't have it in 3, you lost the point. If you didn't have the correct unit, you lost the point.
I have kind of like a weird question.
Go ahead.
You said it applies to chemical and physical changes. So I said
What
it
does?
changed. The energy cannot be created or destroyed.
Mm-hmm.
So like.
And what was the last part of yours?
It applies to chemical and physical changes. So it's kind of implied that it can only change, not be created or destroyed.
And then you got that one wrong.
And you're right, it does apply to chemical physical changes, but you haven't told me energy cannot be created or destroyed, it can only be changed.
So I needed.
Why is the chemical and physical changes?
I forgot to add only changes.
See, the way you phrased it applies to chemical and physical changes, that part is correct. But the energy or matter cannot be created or destroyed. The energy or matter can be changed. And that's why I only give you 1 over 2. Shoot.
Where did I take off the part because of this part or this part? Oh yeah, I know that, but I didn't know.
Because of the last part, only change shape. It doesn't, changing shape doesn't matter. Energy cannot be created or destroyed, it only changes. What that means is the energy or the matter only changes into something different. But it's still there. Okay? Changing shape has nothing to do with it. You can change shape without having the law of conservation matter. Okay? Aiden, here you go. Alright. There are the 2 points to KMT. There's what happens in each of those areas, ladies and gentlemen. FOA is forces of attraction, by the way. Questions? All right. So here's our bonus question, ladies and gentlemen. What 2 elements could we use a lot more of this time of the year? Helium and astatine. Because they make, and it's cold out right now. Now, I do have an idea of an answer in mind. However, if you come up with something that I consider worthy, I will give you credit for it. Okay? I will give you credit for it. So again, if you come up with some combination of 2 elements that would, spell a word that we need more of at this time of the year, go for it. Right? All right, so 16, the first one. Only some particles at the surface are able to evaporate. Why are only some particles able to go to the gaseous state? First of all, you have to have enough kinetic energy to escape forces of attraction. And the only particles can do that are the ones at the surface, because if you have enough energy in the middle of a liquid, you run into particles that stop you from escaping. So you not only have to have enough energy, but you have to be at the surface for that to happen. Okay? Why do particles need to be at the surface to evaporate, not at the bottom or the middle? Oh, sorry. So the first question, I just needed you to tell me that they have to have enough kinetic energy to overcome forces of attraction. The second one, they need to be at the surface. Why? Because otherwise they run into other particles and that stops them from escaping. And the last one, why does the rate of evaporation decrease in winter? Well, because it's colder out. Colder particles don't have as much kinetic energy. They cannot escape forces of attraction as easily. Questions? Please.
I put hydrogen and oxygen.
Because what did you put after it?
Water for snow.
It's not fine.
Okay, I accepted that. I don't think we need more of it, but if you think we do, that's fine. But if you just gave me hydrogen and oxygen and didn't tell me why, then I needed more of an explanation. So, again, on these bonus questions, if it's a question like that and you can come up with some other answer, I will give it to you. Okay? All right, they're yours to keep, ladies and gentlemen. Any questions?
Probably got mine too.
Okay, so here's what you're going to do then. In a minute, you're going to put a note on the top. Did I add the total up incorrectly?
Yes.
Then you're going to put a note on the top that says, please re-add the total. Did I give you too many points and you want some taken away?
No, you gave me 10 less points.
Okay, and that's why I say count them up, make sure, and I will make those corrections for you. Okay? Questions?
I thought I failed.
All right. Cynthia. Jacqueline.
We're not changing something.
Nadia. Haley. Daniela. Levi. Brenda. Rocio. Jenna. Nero. Najma. Rinley. Jen. Aiden. Okay. So what I just gave you, ladies and gentlemen, was a grade report. Okay? On the grade report, there are only 3 categories on there. Well, there is one that is homework, but since homework doesn't count for anything, it doesn't matter. If you are missing a lab, you need to get it turned in, because if you are missing a lab, your grade is lower than it should be. You all have all your quizzes made up. You all have all your tests done. So the only thing you could be missing is a quiz. If you are missing homework, well, tough. Doesn't count for your grade anyway. So you should have turned it in when you had the chance. Now it's too late. Questions? By the way, the question that I have been asked a few times today, can you do retakes? The answer is, if you have less than a 70% on the test, you may do a retake. That is a score of under a 52. So if you had under 52 out of 75 on the test, you may do a retake on it. Okay? Now, here's the rules for a retake. Number 1, they have to be done before the next unit test is given. So that's about 3 weeks, maybe a little less. Okay? Number 2, you need to take your test. You need to make corrections to it. You need to show them to me. Do not erase what you have already there. Make corrections either by circling them in a different color ink, something along those lines on your test. Show it to me, and then you can make arrangements to come in and do a retake test. They got to be done on your own time. You get 1 sitting and you get 1 shot at it. Whatever grade you get on the retake is it. If your grade is higher, I will move it up, but I will only give you up to a 75% on the score. So if you're at a 60, you can improve your score by 15%. Okay? Now, here's the other thing. If you look at your grade report, ladies and gentlemen, if you did really poorly on the test, I still gave you a 50% on the test, even if maybe you only had a 40% or a 30%. In my class, the lowest grade that you can get on an assignment that you do is a 50%, and that includes tests, ladies and gentlemen. So take a look at it. If you have questions, you can ask me. Otherwise, ladies and gentlemen, anything on the test, you need to leave them with me if there is something that I need to correct on them. But on the front page, there better be a note telling me what I need to double check. Please recheck problem 7. Please recheck the total. Please recheck the numbers on page whatever. Because if there is not something there telling me what to do, I will hand it back to you and go, okay, here you go. And it needs to be turned in to me before you leave today. Questions? All right, then let's get to our stuff today, ladies and gentlemen. Take out your computers. Open up to the new EISN that is in Google Classroom. If you go into Google Classroom, ladies and gentlemen, under classwork, here are your answer keys for this unit. Brinley, what can I do for you? I will go grab one, sure. There you go. So here are your worksheet keys. You haven't been assigned all of the worksheets yet, but there are your keys for all of them for the entire unit. Here is your EISN. Here again is the presented notes that I'm going to show to you so that you can see them. If you ever miss anything, you can grab them out of there. Again, ladies and gentlemen, up at the top here is the daily agenda and teaching videos. If you click on that and open this up, ladies and gentlemen, every date that is on there, here is a link to the daily agenda for that day. Here is a link to the video from the class. So the video from the class is done by me taping what is projected on the screen here and what we talk about and what I say in class. So they are there for you if you ever miss a date, if you need to go back and check something, they are there for you. Questions, ladies and gentlemen? We have less than 6 weeks left, and we have 2 units to get through in a final exam, ladies and gentlemen. We will get that done. Okay? What I need you to open right now is your Unit 3 EISN and take a look at it. This unit is the basis for pretty much what we are going to do from here on out, ladies and gentlemen. You are going to have to be able to write and name compounds in this class. If you cannot do that, you will not go much further than you are right now in here. Okay? So this is the basis for what we're going to do. Now, if you're a person who hates math, here's the good news. There is no math in this unit. None. This is all about being able to take 2 elements and write a compound from them, being able to take 3 elements, write a compound from them, and name that compound. Okay? And that is what we are going to be doing. Questions? All right. So, we're going to start out by talking about the fundamentals of bonding. Then we will name binary ionic compounds. Then we will name ternary ionic compounds. Then we will do polyatomic prefixes. Then we will do covalent compounds, and we will end with naming and writing acids, ladies and gentlemen. So that is what this unit is all about. Questions? Good. All right. So let's talk about the fundamentals of bonding, ladies and gentlemen. First of all, almost every element on the periodic table can be involved in a compound, except for one family. What family? 7. The noble gases. The noble gases are group 18. Groups go up and down, ladies and gentlemen. They are the ones in the light blue on the far right-hand side of your periodic table. By the way, please take out your periodic tables. We're going to be putting some notes on it today. What? OG is a newly created element. Now, based on where it is at on the periodic table, it should be a non-reactive noble gas. But we don't know enough about it yet to officially make it a noble gas. It's up to you. It is up to you. You can keep that and work with that, or you can get a new one. But we're going to be putting some notes on it. No, you can only use one on a test. So it's up to you. If you can find the space to put this stuff on there, absolutely fine.
Is it like a good amount?
Semi, but I mean, there you should have some room. Okay, there isn't a ton that is going to go on there. Okay, all right. So, first of all, every element on the periodic table, ladies and gentlemen, every element on the periodic table has its protons and electrons starting out equal. Every element except noble gases will gain or lose electrons to make compounds. Gain, lose, or share them. When you gain or lose electrons, you become an ion, ladies and gentlemen. And oppositely charged ions will be attracted to one another. So you can either be a positive ion or you can be a negative ion. Okay? But when you become a positive ion, you are then attracted to a negative ion. And then you are stuck with each other. What? They're over there, in there. Please, take as many as you need. Okay? So an ion is a charged particle or atom that has gained or lost electrons. And that is the only way you can become charged, is by gaining or losing electrons. Okay? Sodium plus 1 is an ion, magnesium plus 2, oxygen minus 2, chlorine minus 1. Now, here is the other thing that is nice about ions on the periodic table. They are very predictable for most elements, not for all. For most elements, you can predict what charge it will have. And we will go through that in a few minutes, ladies and gentlemen. Okay? Now, all atoms start out neutral. That simply means that their protons and electrons are the same. That is the way an atom starts out. Most atoms do not stay that way. The only ones that stay that way are the noble gases. The noble gases stay that way. Every other element does not. Okay? Now, all atoms start out neutral. When you gain or lose electrons, ladies and gentlemen, you become either positively or negatively charged. If you gain electrons, you have a negative charge. If you gain electrons, you have a negative charge. And if you lose electrons, you have a positive charge. Okay? Now, here is the other thing. An atom cannot just gain electrons from nowhere. The only way an atom can gain electrons is if there is another atom that is near it that is willing to lose electrons. So as an atom, you cannot just go around losing electrons because you want to. There has to be another atom there that is willing to gain the electrons that you are trying to lose. Now, when that happens, ladies and gentlemen, and one atom gains electrons and another atom loses electrons, they are then attracted to one another and bond together. Okay? The charge on an atom can be found by taking the number of protons minus the number of electrons. Now, we will not be making you do this. You did this when you were in physical science if you took physical science. But we will talk about how atoms lose a certain amount of electrons or gain a certain amount of electrons and what charge they will have. Okay, so on your periodic table, ladies and gentlemen, first of all, when you look at the periodic table, tell me something that stands out about this periodic table when you look at it, ladies and gentlemen. What stands out about it? Give me something. Okay, the ladder. Okay. By ladder, what do you mean? Okay, the bold line on here, right? There's one on there. It's not black, it's white. There's one above your head. It's red. Okay. One on the wall over there. Again, it's white. What does the ladder do for the periodic table? What does it tell us? Separation of what? Okay. There's two categories of elements. What are they? Two different kinds of elements. What are they? No. No. What?
Metal and non-metal.
Metal and nonmetals. And that's what that line separates. The metals from the nonmetals. Where are the metals? Metals are on the left-hand side. Metals are things like iron, copper, silver, gold, but also things like magnesium, sodium, lithium, potassium. Those are metals as well. Are there more metals or nonmetals on the periodic table? By far, more metals. Hydrogen, we'll talk about that, because for every rule in chemistry, there is always an exception, and there's no exception to that rule. Okay? Over on the right-hand side and above that bold zigzag line are the nonmetals. Okay? Properties of metal differ greatly from the properties of nonmetals. We're not going to get into that right now. But a metal and a nonmetal are basically what of each other? Opposites. Good. Okay? Good. The other thing that should stand out to you is these elements down at the bottom, ladies and gentlemen. This lanthanide and this actinide series that's down at the bottom. Those elements, the ones down here, ladies and gentlemen, actually belong in these two spots right here. But it's kind of like looking at a map of the United States. Over on the side, they put Alaska and Hawaii. Okay? Over on the side. Why? To fit better on a sheet of paper. That periodic table that's above your heads there, if they take these elements down here and put them where they belong in here, that periodic table goes almost wall to wall. Which means on your sheet of paper, it would need to be twice as wide as it is now. Or the elements and everything would have to be half as small. So to make it so that we can read it easier, we take these elements out and put them down here. Yes?
Do compounds have to be a metal and a non-metal together?
Some do, yes. Some do not. But that is a type of compound, yes. When you have a metal and a non-metal together, that is a type of compound that we will get into. And that will be our first type that we talk about. Okay? A lot of these elements down here, ladies and gentlemen, are not involved in making compounds. Even a lot of the elements in here are not involved in making compounds. It's not that they can't, it's just that there's not a lot of common ones, so we don't worry about them very much. Okay? But the elements here, here, and over in here, they make a lot of compounds. Well, except for the noble gases, which don't combine with anything. Okay? So in reality, here's your nonmetals, but the only ones that combine are these few right in here. That's it. They're the only ones that combine. Okay? Questions? Okay. So, what we want to do, ladies and gentlemen, is over on the left-hand side of our periodic table, we want to write down that these are metals. Okay? These are metals. Now, what does it mean to be a metal? Metals lose electrons. Metals will always, always, always try to lose electrons, ladies and gentlemen. That is what they do. They try to lose electrons. They want to get rid of them. Okay? That is what metals want to do. Now, if you lose electrons, ladies and gentlemen, that means you are going to have a positive charge. Okay? You are going to have a positive charge. Now, on the left side over here, I'm going to write nonmetals. You do not have to do this at the top of your page. If you don't have room, you could do it down at the bottom. You could do it on the side. I don't care. It's your periodic table. If metals lose electrons, what do nonmetals do? They gain electrons. And if you gain electrons, you have a negative charge. So just like Jara was just asking, do metals and nonmetals combine? Yes, they do. Why? Metals are trying to lose electrons. They have to find something else that will gain them. That's a nonmetal. Okay? Metals will lose electrons. Nonmetals will gain electrons. Questions? Okay, so why do atoms combine? What do atoms get out of combining with another atom, ladies and gentlemen? They get what is called stability. Okay? Now, again, we know this not because this is what we want to be true, but we know this because of the noble gases. The noble gases do not combine with other elements. Why? They are already stable. Now, what does it mean to be stable? Well, or how do atoms become stable? They do something called filling their valence shell with electrons. They fill their valence shell with electrons. Aiden, I would pick my head up and I would at least fake like I'm paying attention here. Okay? They fill their valence shell with electrons. Valence shell is the outermost shell. Electrons fill from the inside of an atom out. And think of it like a parking garage. Each level has a certain number of spots. When those spots are filled, you go to the next level. When those spots are filled, you go to the next level. Atoms want their level, the outermost one, to be full of electrons. And again, we know this because the noble gases have a full valence shell. Theirs are full. They don't react. That is why other atoms try to become like them, so that they can be stable and then be the way that atoms want to be, which is a filled outer shell. Now, how do you fill that outer shell, ladies and gentlemen? There are three ways you can do it. You can gain electrons, you can lose electrons, or you can share electrons. That is the only way you can become stable. Now, please tell me which of these three, if you're trying to fill a shell, which of these three doesn't really make sense? Lose. How do you fill something up by losing? That doesn't make sense, does it? Okay. Well, we're going to do a real quick little lesson here, ladies and gentlemen, about something, again, that some of you probably experienced when you were in physical science. But let's take the element lithium. Lithium has 3 protons. So how many electrons does it start out with? 3. Now, here is the nucleus of lithium, the center part. Then the electrons, ladies and gentlemen, are in what we call energy levels, sometimes represented as rings around there. Now, lithium has 3 electrons. There's 1, there's 2, and there's 3. So my example of a parking garage was the first level has to be filled before the second, correct? The first level, because of where it's at and because of how close it is to the nucleus, can only hold 2 electrons. That's it, 2. So here they are. So the third electron goes in this outer level. So how many more would lithium have to gain to fill this level? Well, every level except for the first fills with 8 electrons. So since there is 1 here, how many more would lithium have to gain? 7. Well, that's difficult for an atom to do, to gain 7. Lithium also happens to be a metal, which means it wants to do what with electrons? Lose them. Well, here's how it fills up by losing. If it can give this electron away to another atom, this whole energy level goes away, correct? What do you notice about the level underneath it? There's how you fill by losing. You lose the outermost level completely. However many electrons are in this outermost level, you lose them, all of them. By doing that, the level underneath was full, you become stable. Okay? But what it also means, ladies and gentlemen, is when you lose that electron, you still have 3 protons. But now, once this one is gone, how many electrons do you have? 2. So now you no longer have no charge. What is your charge? Positive 1. So lithium becomes a +1. Okay? Lithium becomes a +1. Again, I'm not the greatest artiste in the world, ladies and gentlemen, but here is the nucleus of the next atom. First energy level, second energy level, third energy level. What element is right below lithium? Which has 11 protons and how many electrons to start out? 11. 2 go in the first. How many can fit in the second? 8. 1, 2, 3, 4, 5, 6, 7, 8. How many is that? 10. Where's the 11th go? Out here. So what is sodium trying to do? It's trying to lose an electron. It is trying to get rid of this electron. Lose it. When it does, sodium will have 11 protons and how many electrons? Which means sodium will be a +1. Any element in group 1 of the periodic table has 1 electron in its outermost energy level, which means all of them try to get rid of 1. And when they get rid of 1, they become stable. So all of them have what charge? Positive 1. All of them. That makes it very predictable. All of those elements will try to lose 1 electron. Okay? Now, what's going to gain that? The nonmetals. The nonmetals. Okay? So let's take a real quick look here at a nonmetal. So let's go to fluorine. How many protons? 9. How many electrons? 9. Okay. There's the nucleus. First level. Second level. Sorry, my circles suck, ladies and gentlemen. How many electrons in the first level? 1, 2. How many in the second?
7.
So what is fluorine trying to do? Gain 1. Here's an electron. It's trying to gain it. Why? Then that outer shell will be full, correct? But it will now have 9 protons and how many electrons? 10. What does that mean for its charge? No, negative. Fluorine will be a -1. So guess what? Fluorine really would like to combine with something in group 1. Why? They're trying to give away 1 electron. Fluorine only needs 1. They make a perfect match. Fluorine says, give me 1 of your electrons. Sodium says, okay. They both become stable. But in becoming stable, fluorine becomes negatively charged. Sodium becomes positively charged. And what do we know about opposite charges? They attract and they're now stuck together. They are now stuck together because they are oppositely charged. Okay? That is how you gain and lose electrons to fill your valence shell. Now, there is another way. We'll talk about it later. That is sharing. Okay? That is sharing, but we'll get into that later. Okay? Questions? So, again, there is a term for gaining or losing electrons, and that is to become an ion. Now, an ion is just any charged atom. Any atom that has a charge. Positive, negative, doesn't matter. Those are the only 2 charges, all right? Positive and negative. Okay? If you gain electrons, you become a negative charge. Non-metals do that. If you lose electrons, you become a positive charge. Metals do that. Okay? Back to your periodic table for 1 second, ladies and gentlemen. Back to your periodic table. Okay? Metals lose electrons, become positively charged. There is a name for a positively charged atom, and that is a cation. Cation is a positively charged ion. Now, again, it could be a single element. It could be a group of atoms together. Anything that is positively charged is a cation. Okay? Now, in physical science, some wise science teacher, not me, thought that it would be a good idea to help you remember cation by giving you a picture of a cat with a smiling face and putting little plus signs in its eyes because cats are a positive thing. No, they are not. Okay? The only good cat is one that I have punted half the length of a football field away from me. Okay? I am not a cat fan. But if that helps you remember that cations are positive, go ahead and use it. And then they had a symbol for a negative ion. Anybody remember what it was?
Was it a dog?
Nope.
No, it was something stupid.
I don't know.
It was an onion.
Yeah.
An onion, because a negative ion is called an anion. An anion. Kind of like an onion. And they said, well, onions make you cry. I said, I like onions better than I like cats.
Yeah.
Nothing, as long as they stay the heck away from me.
You were just talking about punting one across a football field, so I don't know.
Which will make it stay the heck away from me. Okay? Oh, I know they come back. That's why you punt them again.
No?
Okay?
You can't just punt away your problems.
Go resolve them.
You could try. Jacqueline.
No punting.
Like that?
Especially my cat.
Basically, what you're saying is get this stupid thing out of the way. Is that better? Sorry.
You haven't even seen me.
Okay. By the way, I've told you about the rules for things that come live in my house, right? I've never told you about the rules. The rules are, it's simple. If it can stay underwater for 10 minutes, it's welcome in my house. I was there first. It doesn't matter. Unfortunately, I put the rule in after I had kids, too. So
But like it doesn't matter because now it will apply. Just because they create a law after you're born doesn't mean
you cannot penalize somebody for doing something before it was illegal.
But now that
So if you
now
go
that
driving
it is-
through an intersection and they put up a stop sign tomorrow, they can't go back and give you a ticket and say you get a ticket because you went through the intersection
but now
yesterday.
the next time that you go through that intersection.
Correct. So from here on out, in my house, you have to stay underwater for 10 minutes to be
So
welcome.
your kids stay underwater for 10 minutes?
No, because they were in the house before the law was
But
passed.
then they left the house and came back. No.
I leave the house and come back. That's
So-
a dumb point.
You're the one
So-
exception.
yes.
You said every rule in chemistry has one exception. You're the one exception.
You
But
should
your
have
kids
to
are not.
abide by that law. even
I
though
said
it's
every
illegal.
rule in chemistry has an exception, and there's no exception to that
And-
rule. So
and
knock
you-
it off so we can move on to
Right.
questions.
It seems one.
By the way, I am the exception to most rules.
That's what we were saying.
Okay. Oh, by the way, ladies and gentlemen, we did not mention it. We did not talk about it, but we should. And that is, ladies and gentlemen, the element hydrogen. Hydrogen is where on the periodic table, right or left? It's on the left. However, hydrogen can act as a metal. Well, hello, sir. Or a non-metal. Okay? So hydrogen can act as a metal, meaning it can lose electrons, or it can act as a non-metal, meaning it can gain electrons. It can do either one. And here's the reason why, ladies and gentlemen. How many electrons does hydrogen have? One. It is in the first level. So how many electrons does hydrogen need to gain to become stable? One. So it will gain an electron and become stable that way. But hydrogen could also lose one and have none. In which case, it would be positive. So because it's halfway filled, it is not easier to gain or lose. So it can do either one. It can do either one.
Does it depend on the other,
It would be all lonely.
Does it depend on the other what?
like
It depends on what it's around as to what it will do, yes. If it's around metals, it will act as a non-metal. If it's around non-metals, it could act as a metal. Okay? Can do either one. Okay? Questions?
Wait, so
So, I'm waiting. Go.
metals want to have a positive charge?
Metals always want to lose electrons.
Okay.
Because they lose electrons, that gives them a positive charge. Always. Always. That is a for sure.
So even if it's easier to like.
It's never easier for a metal to, let me rephrase that. For every rule, there is an exception, and there's no exception to that rule. Metals always lose electrons, even if it would be easier for them to gain to fill up their outer shell. Okay? Even if it would be easier for them to gain.
And then it's the opposite for non-metals.
Correct.
not really a metal.
Correct. Correct. It's the exact opposite for non-metals. Good.
You're a cat.
Now you're thinking along the way that you need to be successful in this unit. Good. Questions?
So who's the anion?
You.
Okay.
You're my anion.
So they balance each other?
Okay, you two can both be anions, but that's it. You can't be a cation, you can't be an anion.
Me and Joshua?
What about together?
Right, you can't.
How? Why?
Well, because you're the same kind. Meaning you're both females, which means you both need to be either anions or cations. And males are cations, females are anions.
So
Just the way it is.
So,
But I'm literally
so
a
Levi
cat.
can be the cation and you be the anion.
Okay, again,
I
that's
am
some
nowhere
teacher's
near
stupid thing to remember cation. It's not real.
Wait, how does that
It is
work?
too.
How does what work?
Mr. Brian, you
Why am I
What?
want to be a cat?
No, I don't. It says cation, not a cat, cation.
No, I'll
Difference.
be the cat.
Okay,
You're gonna be the man of the race.
Yeah.
okay. So, 8 electrons fill an energy level, except for the first level. Only 2 fill it. And the reason for that is simply because there is not enough room close to the nucleus to fit 8 electrons. And this is not what we think. This is what we have proven time and time again when we have studied the electron structure of atoms. Okay? 8 electrons fill the outer energy level, always. And you always fill from the inner levels to the outer levels. The first level has to be filled before you go to the second level has to be filled before you go to the third level has to be filled before you go to the fourth. Each level that we're talking about represents a period on the periodic table. So periods go across the periodic table. Okay? How many electrons fill the first energy level? 2. How many elements are in the first period? 2. How many electrons fill the second energy level? 8. How many elements are in the second period? 8. How many electrons fill the third energy level? 8. How many elements are in the third period? Coincidence?
Yes.
I think not.
I think
Okay.
so.
Okay?
Wait, so then does the fourth one have 18?
No. 8 fill it. That's it. 8.
Just being extra.
Wait, so
Okay.
there's the example.
Wait, we'll get into it later on.
Okay.
Unit 8, we'll talk about quantum numbers.
Sounds like a lot of
Your head will spin around and pop off of your body, and then you'll understand
So
them.
does period 6
Sounds like a lot of 18s.
Period 6 has 6 energy levels, in which the outermost one holds 8 electrons. Good. All right, ladies and gentlemen. So, we are going to talk about the 8 main groups of the periodic table. The 8 main groups ignore groups 3 through 12. And the reason that we are ignoring groups 3 through 12 is simply they don't fit the pattern that we're going to just talk about. No, they're special. We don't call them stupid. They're special. Okay?
Is that why my
So-
mom keeps calling me special?
What?
I showed them.
Is that why my mom keeps calling me special?
Yes, we'll go with that. Okay? All right. So, groups 1 and 2 and 13 through 18. Each of them has a family name, ladies and gentlemen. Each of them has a certain number of valence electrons, and therefore each of them will have a charge. Why do you have a certain charge? Because you're always trying to fill your outer shell. You fill it by doing what or what? Losing or gaining, and you do what is easiest. You do what is easiest.
Wait, I thought you did
So-
what you do.
Just relax for a minute. Group 1 is called the alkali metals. Okay? Now, which element in group 1 is not an alkali metal?
That
Thank you. Good job, Cynthia. Hydrogen. Why?
one.
Well, you can't be an alkali metal if you are a non-metal. If you are a non-metal, you cannot be an alkali metal. But hydrogen can at times have a +1 charge because it can act like a metal. It's not a metal, but it can act like one. Everything in that group has 1 valence electron, which means you either gain 7 electrons or you lose 1, which is easier. Losing 1. So you become a +1 charge. Group 2 are called the alkaline earth metals. They have 2 valence electrons, which means you either need to gain...
One.
No, not gain
No,
1. 1 would give you 3.
I said what?
That would give you 10.
I didn't hear what you said.
Yeah, what's wrong with it? Wait, you don't have to gain any, do you?
If you want to fill up, how many would you have to gain to be full if you have 2 valence electrons?
6.
You would have to gain 6. To fill up the level, you would have to gain 6. Or you could do what? Lose how many? You could lose the 2 that you have, which is easier. Losing 2. That's why those are a +2 charge. Now we go to group 13. Group 13 is called the boron family. Very original name. The boron family. They have 3 valence electrons. To fill their shell, they either gain 5 or lose, which is easier. So therefore they become a +3. Now we get to the carbon family. They have 4 valence electrons. What? Okay, so which is easier? It's the same. So they literally, you have a +4 and a -4 in the same family. But which ones are the -4?
The
The
metals.
non-metals.
The metals.
The non-metals. Metals are always positive.
I'm so confused.
So the metals at the bottom will be a +4. The non-metals at the top will be a minus 4. No, we'll get to it. We'll get to it.
Okay.
The nitrogen family is group 15. Now we have 5 valence electrons. Now, how many do you have to lose to become stable?
Probably like 5.
You have to lose all 5. Or you could gain 3, which is easier. Gaining the 3. Gaining the 3. So now you have a minus 3 charge. Okay? Levi, you look confused.
I've been confused.
He was just talking.
Do we understand that if you have 5 electrons, it's easier to gain 3 than it is to lose those 5?
No,
Yeah,
why?
but I thought metals only lose.
Don't worry about metals yet. We'll get to that.
Yeah, metals lose an electron.
We'll get to that.
Charge.
We'll get to that.
So
Stop.
they lose a negative. Okay.
Stop. No, don't.
Okay.
Don't.
Okay.
Don't.
Okay.
You're going to confuse yourself.
Okay.
For every rule, there's...
There was like 40 exceptions.
No, there aren't. Oxygen family. Group 16, 6 valence electrons. How many do you need to gain? How many do you need to lose?
6.
Easier to gain the 2 than lose the 6, so they have a negative 2 charge. The halogens, 7 valence electrons. Lose 7, gain 1, which is easier. They have a negative 1 charge. Finally, the noble gases, 8 valence electrons. They don't need to gain or lose any, so they don't.
You smell gases like you're British.
Thank you. I have a cup of tea every day at 3 as well.
Do you really?
No!
Wait.
Noble
Honestly,
gases
I
are
wouldn't be
inert.
surprised.
That means they're unreactive,
Noble
ladies and
gases
gentlemen.
are inert?
Inert! Not a nerd, inert.
Oh,
Are you
one
a
word,
nerd?
inert.
Inert.
Like inertia.
No! Inertia is an object's tendency to stay in motion or an object's tendency to stay at rest.
Actually, according to
Inert.
inertia is a property of matter. Bill. Who's nice guy? You ever
That
watch
was
that?
really
That
funny.
makes me go.
No.
crazy.
That was really fun.
Oh, it's at the bottom. Inert.
Or they're nasty.
Eh.
Were you a nerd in high school?
He's a nerd
He's
now.
a
He's a nerd now. He teaches chemistry.
Oh, job.
Mr. Ness does not teach chemistry.
Thanks, Mr. Ness. I said you do.
You both hold rulers. It's kind of hard to know.
What is he doing with a ruler as a social studies teacher?
Look at the screen.
He likes to whack things with it.
He points at the screen with it.
Yeah,
used to
a lot
whack
of
all
Who
Oh.
gave him a ruler?
He threw it at the wall.
It's
too.
actually
It's
2
like-
yardsticks
I
in
thought it
half
was
and 2.
3.
No, it's 2.
2 yardsticks in 2.
No, they're taped together.
Like they're taped together. They
Yeah.
stand on top of each
He
other.
also
So they're
threw it at the
thick.
Go away.
He threw it
Go
at the
away.
wall.
Monday's another day. Go away. Go away. Goodbye. If you're leaving me your test for corrections, leave it. Goodbye. Go away. Get out.
Oh man. So you're a co-founder.
So, like, give me those points. I need them.
For real.
I gotta go through, make sure I actually made a mistake. You said I was off by 10. I was off by 1.
That's not mine. Can you read?
Oh. I can't. I read 54 out of 57.
Can I use, wait, is this correction?
Recount score.
Yeah,
Can I use this for studying or not?
Yeah, because you need to make
So,
corrections
yeah.
to that and turn that
Well,
in before
I
you
already-
can do a retake.
I already did.
What'd you do? Copy all the answers off the board?
Which one's your recycling?
Walks away.
The
Oh,
blue.
the blue one.
Technically, we still
Can
got
we
one more
recount it in
minute.
front of you?
No, I will take care of it. I will get it graded and then I will return it to you later. Now, you are starting to push your luck with me being nice to you, so get out now.
Technically, we still have one more minute because class is at 42 and 41.
Class ends at 42 and it's 41. When did class ever end at 42?
Oh my god. No.
No, nice try. Go away.
Wait, you have good service on my message was like, I was scared.
She's using you, basically.
Indeed. Mr. Rand, what college did you go to?
UWGB.
We were asking if you were like a know-it-all.
You're probably like one of those kids who like sits in the front and answers all the questions.
Heck no.
This is like
I hated that kid. I hated that kid.
Mr. Brand, I feel like
You were that kid.
No, I definitely was not.